So do you think we should mainly focus on the theory, right? Not worry about the coding part of it, correct?
Yeah, but they might ask one or two coding questions like before.
Sorry?
Yeah, mainly theory, but they might ask one or two coding questions like before.
Like what did they ask last time?
For me, they had asked a program to find a factorial of a number.
Like say the program verbally.
Yeah,
Okay. So I think even if they do, they're just going to ask us like simple questions.
yeah,
We will be prepared. Um, but yeah, we'll focus on the theory as well as the programs. Okay, so I was thinking we should start with the SQL. You sent me that yesterday, right? Link. Okay, I'll share my screen. And good thing is that a lot of people have their exams before us. I think, right? Or no?
yeah.
We might come to know. So what questions and what type of questions they're asking. I mean, are they like on the same day or? Let's see. Biscuit दे में. Let's see. So this is what BSc, PGDCA. I got so much there. No, not really. Actually, it's on the same day, right? So we won't really get much information. It'll be like on the spot itself. Right. Anyways, so let's continue with this. We'll spend some time on the SQL queries. So multiple table queries with joins. This one. So join and inner join establish that if two rows have got the same keys, then we can join those two tables. So inner join is also called You can call it join or inner join. Inner join is a process that matches rows from the first table and second table which have the same key to create a result with combined rows from both tables. After the tables are joined, the other clauses we learned previously are then applied. Okay. So they might even ask us the query, I think. Select find domestic and international sales for each movie. Select domestic sales, comma international sales from box office for each movie, and then you need the movie also. What is that? Come on, it's not getting scrolled. Title. Then you have to join, inner join or just join. Join the movies table on box office dot movie ID equals movies dot ID. Then show the sales a number of for each movie that did better than the internationally than domestically. So select title and then you want sales. So domestic and international sales basically. Let's do international sales, domestic sales from box office, join movies on movie ID dot sorry box office dot movie ID equals movies dot ID, and then where better internationally, which means movies box office dot. There's no need to put dot, right? Or do we need to put dot? Sales is greater than domestic sales. Okay, done. Sumaya, are you there? Select.
Yeah.
Okay. Title by their rating. Rating in descending order. So from movies um, join movies no box office on movies dot id equals box office dot id, and then descending order by something wrong order, yeah, rating.
Remove the underscore.
Continue. So inner join we discussed that It basically allows us to get the data from two tables where the row of the first table matches the key of the second table. Depending on the what you want to analyze, inner join we used last session might not be sufficient because the resulting table only contains data that belongs to both tables. If two tables have asymmetric data, so outer joins are used when tables have asymmetric data, which can easily happen when data is entered at different stages. Then we would have to use left join, right join, full join. Left join means that it keeps the data from the first table irrespective of the matches found in the right or not, and reverse is true for the right join. Full join means it keeps the data for both the table. Okay, so let's try that. Find the list of all the buildings that have the employees. Select building, building name, um, and then name from buildings. I think you have to do distinct, right?
Select building.
I saw that. Um, List all the buildings that have employees.
So you don't have to list the name, right?
Sorry?
You don't have to list the name, right?
Yeah, I guess. Yeah. And their capacity. So capacity means okay. It's going to be building name capacity. Okay. It's all the buildings and distinct employee roles in each building. So we want to ensure that we keep the all the building names. So that's why we'll do the left join this time. So select building name, and then we need the distinct employee roles. So role from buildings, um, outer join. So wait a minute. What did they say? Left join. Left join employees on buildings dot building name equals employees dot building. Yeah, no, nulls. A short note on nulls. As promised in the last session, we are going to quickly talk about nulls values in SQL database. It's always good to reduce the possibility of null values in database because they require special attention. When constructing queries, constraints, alternative null values in the database have the data type appropriate default values like 0 for numerical data, empty strings for text data. But if your database needs to store incomplete data, then null value can be appropriate if the default values will skew later analysis. For example, when taking average of numerical data, sometimes always not possible to avoid the null values, as we saw in the last session when outer joining two tables with asymmetrical data. In these cases, you can test a column for null value null values in where clause by using either is null or is not null. Okay, so let's do that. Find the name and the role of all the employees who have not been assigned the building. We want the name and the role have not been assigned the building. Can I scroll these guys? Want name and the role from employees where building is null. Then find the names of buildings that hold no employees. Select building from employees where, so that hold no employees, where name is null.
I think you have to do a left join here.
Wait, yes, employed 0. Find names of buildings that hold no employees. Oh, okay. Okay. Yeah, I guess so. Yeah, you're right. So we'll have to start from here. Select building name from buildings. I think we have to do right join. Right join we can't do, right? They said that you can't do right join. So left join. Um, okay, but in left join, don't you think that in left join it's supposed to keep all the rows irrespective of the match found or not? That's what the left join says, right?
Yes, it will keep all the rules
But
from
then it's saying
buildings.
names of the buildings that don't hold the employees. Let's see what happens. I'm gonna test it. Left join employees on building name dot it. Oops. Buildings dot employees dot building where uh,
Where name is null.
hmm, yeah, right. Okay, we'll do the so take keep it with you. Let's do this tomorrow, the next part of it. So I'm giving you the link. Please save it and we'll do this tomorrow. Let's move on to some other exercise. So let's go to the theory now. Okay. We'll go fast on the ones that we are confident about and then spend more time on the ones that we're not. So data structure. Data structure are a way to organize the data so they can be store and organize the data so they can be used efficiently. And the classification of data structure. So data structure have linear data structure and non-linear data structure. Then we have the static, dynamic, tree, graph. So in linear, we have static and dynamic. Linear data structure means that the data is stored in a sequence, I believe, and non-linear, which means it's not stored in sequence. And static data structure is like the size of the data is fixed. Dynamic is size can vary. Static we have array, dynamic we have queue, stack, and linked list. Non-linear we have tree and graphs. I have so many animations here. 1 second. Yep. Two types of data structure: linear and non-linear. Linear data structure: data elements are arranged sequentially or linearly, where each element is attached to the previous and next adjacent elements. Example of the linear data structure are array, stack, queue, linked list. Two types of static and dynamic. Static data structure has fixed memory size. It's easier to access the elements in a static data structure. Example of this is an array. Dynamic data structure size is not fixed. It can be randomly updated during runtime, which may be considered efficient concerning the memory space complexity of the code. Example is queue, stack, etc. And the linked list. Let me add the linked list there. Stack, queue, and a linked list. Nonlinear data structure. Data elements are not placed sequentially or linearly. We can't traverse all the elements in a single run. Example is trees and graphs. Arrays. Array is a collection of similar data type elements stored in a contiguous memory location. It doesn't grow at runtime. This is in Java. This is how you declare and initialize in the same line in Java. And this is in C. Multi-dimensional array is an array that can use more than one index to access the array elements. Example in Java, multi-dimensional. And do you remember what's the in this three-dimensional array? What's the first thing called? So this is rows and columns. What's this?
Blocks.
Yep. Okay, this is how you declare it in C. And A34 and these guys. Same thing here, but except that the brackets shift to the data type instead of attaching themselves to the variable. Structures allow us to store different data type together. So the collection of elements of one or more data types. The value of each element of the structure is referred to its corresponding identifier coupled with the variable name of the structure. Struct node in data, struct node in Xperia. So collection of elements having collection of elements of one or more data types. Lists. A linked list is a linear data structure that consists of nodes, and each node contains the data and the pointer to the next node. A linked list is a data structure used to maintain dynamic series of data. I think there's no need to put data structure here. Is used to maintain dynamic series of data. Think of a linked list as a line of bogies of train where each bogie is connected onto the next bogie. If you know where the first bogie is, you can follow its link to the next one. By following the link, you can find any bogie of the train. When you can get into the bogie that isn't holding linked, you know you are at the end. Singly linked list, it is the simplest type of linked list in which every node contains some data and a pointer to the next node of the same data type. The node contains a pointer to the next node that the node stores the address of the next node in sequence. I think this is unnecessary. Single list, linked list allows the traversal of data only in one way. Doubly linked list is a linked list that has uh, different nodes, and each node has data, and then a link to the next node and a link to a pointer to the previous node also. Therefore, it contains three parts. It contains three parts: data, pointer to the next node, and a pointer to the previous node. This would allow us to traverse through the linked list in backward direction as well. Circularly linked list. Circularly linked list is a variation of a linked list in which first element points to the last element and last element points to the first element. The circle linked list is a variation of linked list in which first element points to the last element and last element points to the first element. In singly linked list as circular, um, the next pointer of the last node points to the first node, and in doubly linked list, the next pointer of the last node points to the first node, and the previous pointer of the first node points to the last node. Yeah. Okay. Stack. So stack is a linear data structure um, which follows the first in first out pattern. Elements are inserted from the top and removed from the top as well, just like stack of plates. Stack has one end, whereas the queue has two ends. It contains only one pointer, top pointer, pointing to the topmost element of the stack. Whenever element is added, as it added on the top of the stack, an element can be deleted from the top of the stack. In other words, a stack can be can be defined as a container in which insertion and deletion can be done from one end, known as the top of the stack. Which subject you said you didn't do well in the last exam? Operating system.
Yeah, the practical.
So, like, what were the questions which were difficult?
I don't remember what they were. They were all theory questions.
Okay. Were they like programming related or were they theoretical?
Theoretical.
Okay. Following are some common operations. Yeah, I remember one question I was not able to answer was they asked me how you do this in Windows. I told them stupidly that I don't use Windows. I use Mac. They said, but it's there in the syllabus, right? What can I do? I don't have Windows. I borrowed somebody else's to do the assignment. The following common operation performed implemented on stack pushes the element at the top of the stack, pops the element from the top of the stack. Is empty check if elements is empty. Is full check if the stack is empty. If is full check if stack is full or not. Peak gets the first element of the stack or element present at the top of the stack. Count counts the number of elements in the stack. Change can change an element at a given position, and displays all the elements from the stack. Queues is a linear data structure that follows LIFO pattern, which is last in first out, just like a normal queue at a movie ticket counter. It has two ends, rear and
First in,
front and
first
rear.
out.
Sorry. Oh, did I say? Oh, yeah, you're right. 1 second. Oh, okay. Yeah, you're right. It's so confusing. Cell, in first out. Yeah, fine. It has two ends, front and rear. So elements can be added from the front and removed from the rear. In other words, a queue is a container in which insertion and deletion are done from two different ends. Whenever element at the front is deleted, all the elements are moved. Is something wrong here in this statement?
An element is added in the queue, it should be,
Hmm?
not stack.
Is that all, or there's something else also? See here it says when the element at the front is deleted, all the elements are moved to one position forward, right? So element deleted from the front, but here we're saying element deleted from the rear. So that's what I'm confused about.
In a queue, you can only delete from the rear, right?
Yeah, but then why is it saying whenever element is at the front is deleted?
Or is it the opposite? You delete from the front.
I think it's the opposite. Because think about the queue also. People join the queue from the back. No, they don't
Yeah.
join the queue
Yeah.
from the front. And I'm going to double check. Of course, we know we are correct, but we'll still double check. See, rear. NQ happens at the rear, and DQ happens from the front. That's correct. Are at the rear of the queue, and the elements can be deleted from the front. Queue can be implemented using arrays or pointers. The order of deletion of elements from the queue will be exactly same as the order of addition of elements to the queue. You can draw an analogy of queue data structure to the people standing in the queue for entering a bus. Who travels in bus these days? The following are some common operations implemented on stack. So there's DQ and NQ. I think DQ removes the element, NQ adds the element, NQ will add the element from the rear, and DQ will remove the element from the front of the queue. Then we have few more functions that are required to make the above mentioned queue operation efficient. These are peak, gets the element at the front of the queue without removing it. Okay. Is full check if the queue is full. Is empty check if the queue is empty. That's it. So peak is full and is empty. Okay. A DQ is a special form of queue. You put that. Good. This was an exam. question. A DQ is a special form of queue in which addition or deletion of the elements is possible at the front as well as the rear. So addition or deletion of the element is possible. It's grammatically incorrect. From the front as well as rear. The concept of FIFO does not hold here. Special form of queue, which addition or deletion of the elements is possible from the front as well as rear. Okay. So queue element can only be inserted at the end of the data structure. Elements can be inserted from both, and elements can only be removed from the front of the data. How smart! Just you break, you break this into two statements. This can be removed from both ends of the data structure. Um, Queues are a specialized data structure that uses FIFO approach. DQ can be used to implement the functionality of both stack, LIFO, and queue. Okay, so I think the main thing to remember is it can implement the function. DQ can implement the functionality of both stack and queue, which is LIFO and FIFO. Cool. Trees. A tree is a hierarchical data structure. um, so it has a root, children, and then it has parents, ancestors, and there are nodes which can contain any data type. And each node, the node which doesn't have a children is called what?
Leaf node.
Leaf node. Okay. A tree is one of the data structure that represents the hierarchical data. Defined as collection of objects or entities known as nodes that are linked together to represent or simulate hierarchy. A tree data structure is a non-linear data structure is because it does not store in a sequential manner. It is hierarchical structure as elements in tree are arranged in multiple levels. In tree, topmost node is called root node. Each node contains some data. Data could be any type. In the above tree structure, node contains the name of the employee, so the type of data would be string. Each node contains some data and the link or reference of the other nodes that can be called children. The nodes that do not have children are called leaf nodes. General tree is a tree in which each node can have many child nodes. Binary tree, each node can have at most two nodes. That's why the degree of the general, there's no limitation on the degree of the node for general tree, but there's a limitation on the degree of node on the binary tree because they can have at most two nodes. Yeah, two child nodes. In general tree, there's either a zero subtree or many subtree. In binary tree, there are two subtrees, left tree and right subtree. Subtree of a general tree do not hold ordered property. Subtree of a binary tree hold the ordered property. General tree cannot be empty, while a binary tree can be empty. Binary search tree. A binary search tree is a binary tree that is either empty or a node containing a key value, left child, empty, or is either empty or has a node containing a key value, left child, and a right child. So binary search tree is a binary tree that is either empty or has a node containing a key value, a left child and right child. The non-empty binary search tree satisfies the following condition. The key in the left child of the node is less than the key on in its parent node. The key in the right child of the node of a node is greater than the key in its parent node. Should we call it value or key? I'm just wondering. The value of the left child node should be less than the parent node. The left and the right subtrees of root are again binary search trees.
What
Okay.
if it's equal? Then does it go on the left or right?
What? What if it's equal?
Yeah.
It doesn't matter, right? You put it on the left or right. It doesn't really matter because they both are going to be equal. So it doesn't matter where you put them. Binary search tree. A tree is balanced if for all nodes the difference between the height of the left subtree and the right subtree is not greater than 1. So like 15 plus 10 plus 8, I guess, plus 12. Height, how is the height calculated? Is it the values, sum of the values of each nodes?
No, it's the height of the tree.
How is the height of the tree
The
calculated?
levels.
Is it 1, 2, 3?
Yeah, the levels of the nodes.
So for this one is going to be 1, 2, 3, 4, 5.
Yeah.
Height is equal to the largest number of edges from the root to the most distant leaf node. Most distant leaf node is this one. Okay, so first we calculate the height of node C. So according to definition, the height of the node C is the largest number of edges in the path from the leaf node C. We can see there are two paths, C to E to G and C to F. The largest number of edges among these two paths are 2. Hence the height of the node is 2. Is it not counting the one we have? We're just counting these two, I guess. Now we'll calculate the height of the binary tree from the root. We can have three different paths leading to the leaf node A, C, F, A, B, D, A, C, E, G. Amongst these three paths, the path A, C, E, G contains the largest number of edges, which is 3. Okay, so we just have to calculate. We just find out the most distant um, node, and then see what's the number of nodes from the root. And we don't include root in that. So in this case, it'll be 1, 2, 3. We're not going to include the root node. Okay. So in this case, this is the one. So it's going to be 1, 2, 3, 4. 4 is the height of this tree. And in this case, the height of the tree is 1, 2. Clear? You have any question?
Sorry, I had to go get the door. What did you say?
Sorry? How to get the total? So see
Yeah.
which is the most distant node from the root. In this case, I can pick up any of them, right? Because all of them are like at the same like largest distance from the node. So
Okay.
this is, you can count this or this. So if you see this, then how many number of nodes are there from root till here? So there are two. We don't include this one, so that's why it's 2.
Okay.
In
Okay.
in this, let's say another example. In this one, what's the most distant one? in this diagram,
The bill
which is
node.
Bill. Yes. So how far is it from how many nodes between John and Bill? So like one, two, three, four. So we'll count number of nodes, but exclude the root. So it's
Okay.
four.
Okay, got
If we are if we are getting the height of the left subtree, then it's going to be any of one of these. So this one, so it'll be one, two, and that's it. Move on. Splay trees. Splay trees is type of binary search tree that uses splaying operation on the tree. So most frequently used elements can come closer to the root. So type of a binary search tree that uses splaying operation, like spreading operation on the tree. So most frequently used elements can come closer to the root. A splay tree contains same operation as binary search tree, insertion, deletion, and searching, but it also contains one more operation which is splaying. To search any element in the splay tree, first we'll perform the standard binary search tree operation. As 7 is less than 10, so we'll come to the left of the root node. After performing the search operation, we need to perform splaying. Here, splaying means that operation we are performing on any element should become the root node, and after performing some rearrangements. Rearrangement of the tree will be done through rotation. So it's saying that if 7 is the element you're looking for, the first thing you do is follow the normal process of the binary search tree is to search that element and get to that element. Once you get to that element, then we need to say that that becomes whatever we are trying to search becomes the root now, and then we have to basically rearrange this whole tree in a way that that becomes the root now. Instead of 10, 7 becomes the root. So in this case we are rotating it towards the right to make the 7 as the root node. So that's what splaying means. Basically it's type of a binary search tree that uses splaying operation. So most frequently used elements can come closer to the root. Red black tree is the type of binary search tree with one extra bit of storage per node, and that's the color, which could be either red or black. The root has to be black, I think. Each node of the tree should be either red or black. The root is always, yeah, root is always black. If a parent is black, child has to be red, I think. If a node is red, then children should be black, and vice versa, I guess. Yeah, 1 second. No, that's not true. What I said. If the parent is black doesn't mean the child has to be red. The only rule is that if the parent is red, then child has to be black. A node Z is inserted using the same procedure as BST, binary search tree. Z is colored red. Rotation and or coloring is performed to retain the red black tree's properties. Four scenarios. If Z is the root color, it's black. If Z dot uncle is equals red, then recolor Z's parent, grandparent, and uncle. Z dot uncle black triangle, then rotate Z's parent. Okay, we'll do graphs tomorrow. Just remember that. Just remind me that we're supposed to start from graph because you can't cover everything in one day. So we're gonna be doing like starting from one slide, reaching until certain slide, and then uh, second day again we'll pick up from where we left until we are finished. We'll repeat this process until we finish all the slides, and then repeat again from the start. Okay,
okay.
cool then. Thanks, Maya. Good night.
Bye.
Bye.